Exercise 3.2. Find out all the you can about natural language interface. Are there any successful system? For what application are these most appropriate? Answer. This exercise is intended to encourage the student to do some personal research into the form of a brief literature survey. Volunteer can be given the appropriate place to begin such as research. For example, general textbooks on artificial intelligence will include basic information on natural language processing and famous systems such as SHARLU, HARDLU, proceeding from the conference such as the AAI, and specialist journal will have more up-to-date research paper in the area proceeding of HA conference such as CHI inter inter interact and HCI will be included in natural language systems, particularly geared toward the interface. Other like sources are popular journals such as Byte and Personal Computer Magazine, which are likely to review commercial systems. The student response to the second part of the question will depend upon what the unearthed, but it's likely that the system they find out about operate in very constrained domain and that the natural language use is restricted. That there are as yet no general purpose natural language interface. Exercise 3.3. What influence does the social environment in which you work have on your interaction with the computer? What effect does the organization, commercial or academic, to which you belong have on the interaction? Answer. The aim of this exercise is to get the student to explore the social and environmental influence which affect interaction, often without the user being aware of them. The particular influence will vary from environment to environment, but the students should be encouraged to consider some or all the following. Work context. Is the workplace shared? Are the machines shared? Peer. Pressure. Is the pressure to the complete or impress? Management pressure. Is the pressure to achieve? Is the interaction carried out in the presence of management? Motivation. What motivates the interaction? Does this encourage or discourage experimentation? Organization goal. What is the objective of the organization? Profit, education. How does this affect the interaction organization decision making? Who determine the system that you use? Do you have any choice or influence? Does this influence the way you interact with the system? In each case, the student should discuss what influence this may have on the interaction. It may be helpful to consider other possible environment in order to identify how the interaction would differ under these different circumstances. For example, if the student currently share a machine with the colleagues, will his or her interaction practice change if she or he was given a private machine? Chapter 14 also discuss the influence of group of the work within an organization on the an interaction and is suggests as future reading material on this topic. Chapter 4. Usability paradigms and principle. Exercise 4.1. Look up and report back guidelines for the use of color. Be able to state the empirical physiological evidence which support the guidelines. The guidelines conflict with any other knowledge. No guidelines. Which principle of interaction do they support? Answer. There are many examples of guidelines for the use of the color in the literature. Here are three good sources. Brown Cimarlin Human Computer Interface Design Guidelines, Ablex 1980. Matthew Deborah G. Principle and Guidelines in Software User Interface Design, Prentice Hall 1992. Sun Microsystem Inc. Open Loop Graphical User Interface Application Style Guidelines, Addison Wesley 1918. Taking an example from the Matthew, we have the following design guideline for the use of the color as an informational cue for the user to inform the user that a string of text is a warning or error message. Do not use color without some other redundant cue. Mayhew provide 3 reasons which empirical support this guideline. 1. Color may not be able on the all machine on which the system is to be implemented. Therefore, its use of color is the only means to convey some important information to the user. Then, the information will be lost in the monochrome not color system. Redundant color coding will allow for portability across different computing platforms. 2. Empirical evidence show that 8% of the general male population and 0.4% of the female population had some color deficiency, so they cannot accurately recognize or distinguish between various colors. Again, if color is the only means for conveying some information, this significant portion of the user population will be selected. 3. It has been shown the redundant color coding enhances user performance. This guideline supports several of the principles discussed in this chapter. Substitutivity. The system is able to substitute the color code information and other means taxon to represent some important information. We could turn the argument around and suggest that then the user be able to provide color input by selecting from the palette menu, or other form of input provide relevant information to the system. Observability. This principle is all about the system being able to provide the user with enough information about its internal state to assess the user task. Relying strictly on the color code information as pointed out above could reduce the observability of the system for some user. Synthesis. If a change in color is used to indicate the changing status of some system entity, perhaps a change in the temperature above threshold value is signaled by an icon become red. Those who cannot detect the change in the color would be deprived of this information. Synthesis is about supporting the user ability to detect such significant change, especially when they are a result of previous user action. There is no evidence of existing guideline with this particular guideline for color violet. Another example for color guideline found in all three of above reference is the demand to consider cultural information in the section of particular color. For example, Mayhem state that the Western culture tend to interpret green to mean go or safe, red, red to mean top, on hot or emergency, and blue mean cold or off. Using color to suggest the kind of meaning is in support of the familiar principle within learnability. However, in other cultures, different meaning may be associated with this color and consistent use of color. Another guideline might lead confusing, hence strict adherence to the guideline with a suggest a violation of the consistency of the color application guideline. However, if consistency applied relative to the meaning of the color as opposed to its actual color, this guideline will not have to complete. Exercise 4.2. What was the problem with the synthesis example comparing a common language interface with a visual interface? Can you suggest a fix to make a visual interface really immediately honest? Answer. It is example to demonstrate the principle of synthesizability within learnability. It was stated that a visual interface to a file management system provides immediately information about the change location of some file after a move operation performed by the user. In the contrast, a common language interface requires the user to remember the direction to which file was moved and explicit issue command to browse the direction to verify that the file has been removed. To really be sure that the move accurate, the user will have to also browse the original direction to determine that the file is no longer there. The fallacy in this argument is that visual file management system do always provide information about the new whereabouts of the move file. To take a counter example using the Macintosh example from the text, if the file moved from the one open folder in which the content of the folder revealed to the user to the closed folder content not revealed, then the location of the move file is not indicated to the user unless she remembers to open up the destination folder to reveal its content. This is an example of eventual honestly and not immediately, as the example suggests. We could fix this problem of eventual honestly for the visual system by demanding that destination folder be an open folder, probably too restrictive given the limited screen size, or by having the destination folder temporarily open up to reveal that the file is now located within it. This last suggestion is also a bit tricky, for we would still want to determine that the file not longer resided in the original folder. So we will have to be sure that the new folder does not obstruct the view of the older folder. In practice, this might be too difficult to grant it in general. Exercise 4.3. It has been suggested in this chapter that consistency could be considered a major category of interactive principle on the same level as learnability, flexibility, and robustness. if this had been the case, which principle discussed in this chapter will appear in support consistency. Answer. As mentioned in the discuss of consistency, it can take many forms because consistency is usually referred to relative to some other feature of the interaction between user and system. Mentioned already in the text, we have consistency related to the following principle. Familiarity, consistency with respect to the prior real-world experience. Generalizability, consistency with respect to experience with the same system or set of applications on the same platform. In addition, we could interpret some other principle as contributor to consistency. Affordance, consistency with the understood intrinsic properties of an object. So, a soft button on the screen should allow us to always push on it to select some action. Predictability, consistency of system response with user expectation given the user has some information about past interaction history. Substitutivity, consistent permission from the system to allow use of equivalent values for the input and output. Commensurate effort, consistency of effort with respect to doing and undoing tasks. Response time, stability, consistency of the system response for similar action. Some other principle for consistency from the text and elsewhere. Consistency can be relative to the form of input or output expression relative to use conceptual model of the system. An example in the text involves using keyword relative position are similar to command for the system. Any set of view type-rated key which form diagonal to indicate up, down, left, and right information for an input command. As discussed in the exercise on color, consistency can be with respect to social or cultural convention. Using the red to indicate stop or hot, green for go, blue for cool. Exercise 4.4. Discuss the way in which a full-page word processor is or is not the right manipulation interface for editing a document using Schneiderman criteria. What feature of the modern word processor break the metaphor of composition with pen or typewriter and paper? Answer. We will answer the first question by evaluating the word processor relative to the criteria for direct manipulation given by Schneiderman. Visibility of the object of interest. The most important object of interest in a word processor are the words themselves. Indeed, the invisibility of the text on the continual basic was one of the major usability advances in moving from line-oriented to display-oriented editor. Depending on the user application, there may be other projects of the interest in word processing that may or may not be visible. For example, are the margin for the text on the screen similar to the one which would eventually print? Is the spacing within a line and the line breaks similar? Are the different font and the formatting characteristic of the text visible without altering the spacing? Expressed in this way, we can see the visibility criterion for the direct manipulation as very similar to the criteria for the WYSIWYG, what you see it was you get interface. Incremental action at the interface with the rapid feedback on the all action. We expect from the modern word processor that the characters appear in the text as we type them it out at the keyboard. With a little delay, if we are inserting text within a paragraph, we may also expect the formula of the paragraph adjusts immediately to accommodate the new change. Various word processors do things for reformatting automatically, whereas others do it occasionally or only at the explicit request of their user. Another important action which require incremental and rapid feedback is movement of the insertion point, usually by means of arrow key. If there is a significant delay between the input command to move the insertion point down one line and the actual movement of the cursor on screen, it's quite possible that the user will overshoot the target when repeatedly pressing the down arrow key to move down a few lines on the screen. Reversibility of all action, so that the user are encouraged to explore without severe penalties. Single-step undo command in the most word processor allow the user to recover from the last action performed. One problem with this is that the user must recognize the error before doing any other action. More sophisticated undo facility allow the user to retrace back more than one command at a time. The kind of the exploration this reversibility provides in a word processor is the best evidence with the ease of experimental that is now available for formatting changes in the document font type and size and margin change. One problem with the case of explorating is the emphasis may move the look of a document rather than what the text actually say, style over content, synthetic correctness of all action, so that every operation is legal operation. WISY word processor usually provide menu and button which the user use to articulate many commands. This interaction mechanism serves to constrain the input language to only allow legal input from the user. Document production system such as draft text and script force the user to input textual command which may be erroneously entered by the user. To achieve desired formatting effect, replacement of complex command language with action to manipulate directly the visible object. The case for word processor is similar to the described above to synthetic correctness. In addition, operations on portion of the text are achieved many times by allowing the user to directly highlight to the text with the mouse or arrow key. Subsequent action on the text, such as moving it or copying it to the somewhere else, can then be achieved more directly by allowing the user to drag the selector via the mouse to its new location. To answer the second question concerning the drawback of the pen or typewriter metaphor for word processing, we refer to discussion on the metaphor in section 4.2.6. The example there compare the functionality of the space key in the typewriting versus word processing. For a typewriter, the space key is passive. It's merely moved in the section point on the space to the right. In the word processor, the space key is active, as it the answer character as a character, the space character into the document. The functionally the functionality of the typewriter space key is produced by the movement key for the word processor. Typically, an arrow key pointing right will move forward within one line. In fact, much of the functionality that we have come to expect of a word processor is radically different from the aspect of a typewriter. So much so that the typewriter as a metaphor for word processing is not all that instructive. As practice modern typewriters have begun to borrow from word processor when defining their functionality. Chapter 5: The Design Process. Exercise 5.1. Starting with the sum of the principle outlined in the chapter 4. Provide a usability specification for an electronic meeting, diary, or calendar. First, identify some of the tasks that will be performed by a user trying to keep track on future meeting, and then complete the usability specification assuming that the electronic system will be replacing a paper-based system. What assumption do you have to make about the user and the electronic diary in order to create a reasonable usability specification? Answer: this exercise could be easily extended to small projects which would involve the design of such an electronic diary or calendar. The purpose of this smaller usability engineering exercise is to show how usability goals can be formulated early on the drive the design activity. We will select two of the usability principles from the chapter 4, which will serve as attribute for separate usability specification. In the first example, we will consider the interaction principle of usability, which concerns how easy it is for the new user to perform tasks initially. The measuring concept will be how long it take a new user without any instruction on the new system enter their first appointment in the diary. A sample usability specification is given below. Attribute usability measuring concept is the first use of the system without training. Measuring method time to create first entry in diary. No level 30 seconds on the paper-based system works. Case 1 minute. Planet level 45 seconds. Best case 30 seconds equivalent to no. The values is the usability specification might seem like little surprising first since we are saying that the best case is only equivalent to the currently achievable. Achievable level no. The point in this example is the new system is replacing its very familiar paper and pencil system, which require very little training. The objective of the system is not so much improve usability but to preserve it. In the chapter we discussed that the worst case level should not usually be worse than the no level, but we're hoping for this product to improve overall functionality of the system. The user will be able to more things with the electron diary than they will call with the conventional system. As a result, we worry less about improving its usability. Perhaps we could have been more ambitious in setting the best case value by considering the potential for voice input, the other exotic input technique which would make entry faster than writing. As another example, this time within the flexibility category, we want to support the tax migrability of the system. A frequent sort of the task for the diary is to schedule weekly meeting. The conventional system will require the user to make an explicit entry for the meeting each week. The task of the scheduling is the responsibility of the user. In the new system, we want to allow the user to push responsibility of the scheduling over the system so that the user need only indicated the desire to have meetings scheduled for a certain time each week, and the system will take care of entering the meeting of the appropriate time. The task of scheduling has to migrate over the system. The usability specification for this example follows: attribute task migrability, measuring concept, scheduling a weekly meeting, measuring method, time it takes to enter a weekly meeting appointment, not no level, time to schedule one appointment, number of week, worst case, time to schedule 2 appointment, plan level 1.5, time to schedule 1 appointment, best case, time to schedule 1 appointment. In this specification, we have indicated that the no level is equivalent to the time it takes to schedule each appointment separately. The worst plan, the best case level are all target at some proportion of the time it takes to schedule just a single appointment, a dramatic improvement. The difference between the worst plan and the best case level and the amount of overhead it will take indicated the single appointment is to be considered an example to repeat at the weekly level. What are assumptions we have to make in order to arrive at such a usability specification? One of the problem with usability specification, as we have studied in the chapter, is that they sometimes require specific information about the design in the order to be expressed. For example, had we set one of our measuring method to accounts stroke or mouse click, we would have had to start making assumptions about the method of interaction that the system would allow. Had we tried to set usability specification concerning the browsing of a diary, we would have had to start making assumptions about the layout of the calendar.